Rainbows have captivated humanity for millennia, inspiring myths, legends, and scientific inquiry. But what exactly is a rainbow and how does it work? In this video, we'll unravel the fascinating science behind rainbows, exploring how they form, what they're made of, and the intricate processes that bring this natural wonder to life. Let's dive in. A rainbow is an optical and meteorological phenomenon that manifests as a spectrum of light appearing in the sky. It takes the shape of a multicolored arc, with its colors transitioning seamlessly from red on the outer edge to violet on the inner edge. While rainbows are commonly associated with rain, they can also occur in the presence of other water droplets, such as mist, dew, or spray. Interestingly, rainbows are not physical objects but optical illusions that depend on the viewer's perspective. The formation of a rainbow begins with sunlight, white light that contains all colors of the visible spectrum. When sunlight encounters a water droplet suspended in the atmosphere, it undergoes three key processes: refraction, reflection, and dispersion. First, as sunlight enters the water droplet, it slows down and bends, a process known as refraction. This bending occurs because light travels more slowly in water than in air. The degree of bending depends on the angle at which the light enters the droplet. Next, the light reflects off the inner surface of the droplet. The angle of this internal reflection determines how much light will exit the droplet and contribute to the rainbow. In some cases, multiple internal reflections occur, leading to secondary or even tertiary rainbows. Finally, dispersion occurs as the light exits the droplet. Different wavelengths of light bend by different amounts, causing white light to split into its constituent colors. Shorter wavelengths, such as blue and violet, bend more sharply, while longer wavelengths like red bend less. This separation creates the spectrum we recognize as a rainbow. Rainbows are composed of 7 primary colors: red, orange, yellow, green, blue, indigo, and violet, often remembered by the acronym ROIG-BIV. These colors appear in a specific order due to their wavelengths. Red, with the longest wavelength at approximately 650 nanometers, is refracted the least, while violet, at around 400 nanometers, is refracted the most. The smooth gradation between these colors is due to the continuous nature of light spectrum. Not all rainbows are the same. Here are a few variations you might encounter. Double rainbows occur when light is reflected twice within a droplet, creating a secondary arc with reversed colors. The area between the primary and secondary rainbow, known as Alexander's band, appears darker due to the absence of light. Supernumerary rainbows appear as faint additional bands inside the primary arc, caused by interference patterns in light waves. These are more likely to form when water droplets are uniform in size. Fog bows, also known as white rainbows, form in fog and appear faint due to the small size of the water droplets involved. Their colors are often muted or absent altogether. Circumhorizontal arcs, sometimes mistaken for rainbows, occur in high-altitude cirrus clouds and require specific conditions, including a high sun angle. The science of rainbows is rooted in the physics of light. Snell's law governs the refraction of light as it transitions between media, described mathematically as n1 asterisk sin, v1, equal sign n2 asterisk sin, v2, where n represents the refractive indices of the media. The angle of internal reflection must exceed the critical angle, about 48 degrees for water, to produce a visible rainbow. Additionally, the interplay of constructive and destructive interference shapes the vividness and sharpness of the rainbow's colors. A rainbow's appearance depends on the observer's position relative to the sun and the water droplets. The sun must be behind the viewer, and the center of the rainbow's arc lies directly opposite the sun. This geometry creates a circular cone of light with the viewer's eye at its apex. The radius of the primary rainbow's arc is approximately 42 degrees from the anti-solar point. From elevated vantage points, such as an airplane, the full circle of the rainbow becomes visible, offering a rare and spectacular sight. Throughout history, rainbows have held deep cultural and symbolic meaning. In Norse mythology, Bifrost was a rainbow bridge connecting Earth to the realm of the gods. In Hinduism, rainbows symbolize the bridge to spiritual enlightenment. Modern science views rainbows as an elegant demonstration of optical principles, shedding light on the interaction between light and matter. They also play a role in environmental monitoring, as their appearance can indicate the presence of specific atmospheric conditions. Rainbows are more than just beautiful phenomena. They are a testament to the elegance of nature and the principles of physics. The next time you see a rainbow, take a moment to marvel at the incredible processes that create it. If you enjoyed this video, don't forget to like, subscribe, comment, and hit the notification bell. Thank you for watching, and we'll see you next time.